Hello. Today we're going to be going over creating a temperature sensor with a simple web server to output the data on a ESP8266. So the agenda for today is really to look at the problem, the requirements for said problem, an overview of the design, review the code, and then finally a short example demo. The problem that we're looking at is to integrate a temperature sensor with the ESP8266 and finally export that data of temperature and time in a CSV format. I chose to export over a web server and serial, but that can be implemented however you would like. So the requirements that we're going against for this is to develop in a language executable on Arduino, C, C++, execute on an Arduino microcontroller, utilize round robin with interrupt design, transmit that reading via CSV file format, and transmit reading via serial, save temperature in Fahrenheit, and then plot that temperature versus time. That plotting can be handled externally as well, either in a spreadsheet or utilizing something like matplotlib as I do later on. Now let's look at our design of the actual software that will be running on the Arduino platform. First we have our start, then we have our setup function. Inside this setup function, we start a serial, we initiate our Wi-Fi for our web server that will be used to export the data. We start an NTP client over that initialized Wi-Fi. This is really just to get the time. We attach the interrupt to follow our interrupt design with round robin at a 10-second interval, and then we start our DHT reading, which is the sensor that we are utilizing for this application, and then we create and start our web server request handler. Once we finish our setup, we go into our main loop, and our main loop is where we're actually doing the reading of our sensor, and then we're also doing some serial reading as well. So we first start off by getting the serial, and we check either for a stop value or we check for the keyword values. In this case of that keyword, we actually just return the CSV data over serial. That we'll demonstrate later on. And then we check millis if 2 seconds has passed. If it has, we disable the interrupt, and then we read that temperature, save temperature value. We read the humidity and save it, and then we also get our epoch time from the NTP server, and we save that epoch variable. Then we finish up that main loop by enabling the interrupt. To go over our interrupt, it's pretty straightforward. We're just using our interrupt to save the temperature data. So for this, we copy humidity and temp and time to a CSV character array, and then we concatenate that data character array with the new humidity. So this data character array contains all of the data for that temperature readings, and then we concatenate it with the new data. For the web server request handler, we actually just set it up as a simple GET request, and then we just return that CSV data object over that web request when it's performed. So now that we've gone over the software kind of flow diagram, let's look at the physical connections. So I'm using this breadboard with the ESP8266 over here. We can see that the orange pin is our actual power. That is going to the far left pin. Again, if you lay it flat, the DHT11 sensor, from left to right, it goes power, output, and then ground. This green wire is our ground, and then this yellow wire is our output. This is connected to the D1 pin on the ESP8266. It's the middle pin on the DHT11. It is important to remember that the pinout labels on the actual ESP8266 aren't the actual pin numbers that you'll be using in Arduino IDE or Platform IO, something along those natures. I recommend looking it up. I do know that D1 does reference pin number 5. So now that we have gone over the software flow, we've gone over the physical connections, let's look at the code and kind of what environment that I used. So I recommend downloading Platform.io for VS Code and installing that. I think the dependency management is just a little bit better and the actual customization is a little nicer. Um, so there are three main libraries that I used for this project. I used the ESP async web server. That comes with a dependency of ESP async TCP, and then I also used the NTP client. I also used DHT test, but I migrated from Arduino IDE, so that was already installed as well in the Arduino libraries section for the IDE, which is linked to this library. So now that we have gone over our dependencies, let's look at our actual code. Really at this top section, we're just defining the DHT pinout and the objects. We're defining some intervals with regards to interrupts, and then also with regards to how often we want to take a temperature reading. Then we're defining the interrupt flag and really interrupt millis. Really, I used this section of variables to kind of just validate that I'm interrupting at the right time frame. Then we have some empty variables really that are just for our now, which is our time and epoch, our temperature, and then also our humidity. Then we have our general CSV data object character array with its headers already defined and it positioned to go to the new line. Lastly, we have our Wi-Fi information, and then we have our NTP setup and our async web server configuration. So trying to connect on port 80, and then it's just a normal /. So we have three functions. The first one is to initialize our Wi-Fi. The second one is to get time. This just handles calling the time client's update and then getting the current epoch time, reaching out to that NTP server. And then we have our interrupt, which really just creates an empty buffer for temp. And then we use sprintf to copy in a character string or character array with our defined variables, so now t and h, into our temp buffer, and then we concatenate the CSV data that was done at the top of the file with our temp data. And then we also set this interrupt flag. This can be removed. This is really just for validating that timing like I mentioned earlier. So now that we've gone over our three functions, let's go to our setup. Again, like we talked about in the flow diagram, we start our serial, we then initiate Wi-Fi, start our NTP server, create our general web server. We define the request, so on a /get request, we just return that CSV data and a 200. We set up our initial DHT so it can start running the sensor, and then we attach our timestamp, or not our timestamp, our timer for our interrupt. We use the loop function so we don't have to constantly write the interrupt interval to the registers, and then we print out some helpful information here. After we have our setup, we start going into our loop. In that loop, we run a serial. We check if serial is available. If it is, we check if we should stop, or we check if the serial is equal to values, which would then just return that CSV data. From there, we have our conditional check for if that interrupt flag is true. If it is, we just print out that interrupt timing, which is really just the current milliseconds minus the interrupt milliseconds. And then we set our interrupt milliseconds to the current and reset the flag. This section can all be removed. It was just for testing purposes. Next, we check if our current versus previous millis is greater than our sensor interval. If it is, we disable that interrupt timer, and then we set our previous millis equal to current, and then we work on getting the timestamp, and then we also pull in the current temperature and current humidity. It is important to realize that if these aren't valid reads, then it'll just default to what the last value was. And then at the end of that, we re-enable our loop. So now let's go into a demo. On the screen, we can see that we have our sensor platform, and then on the website, we can see that we have our CSV data. So let's go ahead and size that up so we can see a little bit closer. And then let's go ahead and actually restart our sensor. So we have our sensor restarted. Let's refresh our page. We can see that we have some empty data here. While that's loading, let's go over how we're going to actually plot it. Again, this will take 10 seconds for each read, so we'll go over our plotting information first, and then we'll return to this with some more data. So I use Jupyter Notebooks and Python 3 to handle all my plotting. I installed matplotlibs, and then I also installed requests to get the data from the embedded device. So we start off, we import our standard libraries, which is really just datetime, CSV, OS, and time, and then matplotlib and request. I set the CSV, embedded CSV URL, which is equal to the IP of the device that we're using. And then for requesting data, we do a simple GET request to that CSV. We get the text data from the response. Important to realize that we are getting text, not JSON. This is because we're just returning that CSV data as the actual loaded page. And it also gets content plain text type. So next we actually take that CSV data, we parse it to a reader, and then we loop through that reader and append the different data types to the lists of their own. So we have a timestamp, temp, and humidity list, and we handle the skipping of the actual headers at this front section. So if we do the split line here, and then we say from 1 to the end, that'll skip through the headers so they don't corrupt any of our data. From there, we actually use matplotlib, and we can plot temperature versus time, and then we can also handle plotting that humidity versus time. So if we go back to our web server, we can see we got some data. Nothing too wild here. We just have some simple ambient temperature. But now if we go back and we rerun our requests, and then we parse that request, and then we can handle plotting that data. We can see that it went from 77.7 to 77.9. We can see that reflected in the graph as well. Lastly, our humidity stayed the same throughout, so you can see we got 38 for all of them. Next, let's move on to the actual serial output. I still use Arduino IDE for the serial monitor. I think I just haven't learned about the platform IO enough to use their serial monitor, but I have no doubt that I'll migrate in time. So from the top, we can see that we have our simple load. We have the connecting to Wi-Fi. It prints out our IP address, and then we also have just a quick little welcome message. So let's start off by first getting the values. So to do that, we just input in all capitals values. We click send, and it'll actually handle writing out the timestamp, temp, humidity in Fahrenheit, and then so we have our values returned over serial in CSV, and now if we enter stop, it'll actually call the exit function and throw in a bullet code. So that is the overview of the temperature sensor, and thank you guys.